This is the third video in Mr. Loftness Maths National 5 Maths Statistics series. The previous two videos, the first of which is some revision on mean, median, mode and range, and the second video on quartiles and semi-interquartile range. The learning intention of this video will be box plots, comparisons between box plots, and the 5-figure summary. The latter of which may have different names. You may also know it as a 5-number summary. You may not know it as anything at all. You may just consider the quartiles. But in this video, we will be referring to it as a 5-figure summary. So I've laid out some of the things you should need if you are taking notes from this video. Because we will be drawing some diagrams, I would definitely recommend use a pencil at some point. And I've got a ruler here as well to make sure those diagrams are neat. So why do we need those? Well, we're going to start off with some definitions of our learning intention. So the first thing we've got there is a box plot. And a box plot is a statistical diagram used to illustrate the spread of a set of data. So that word spread's coming up there again. I'm actually just going to underline that word spread there because it's came up again and again. We talked about spread when we spoke about range, when we spoke about quartiles, when we spoke about interquartile range and semi-interquartile range. And it's just how spread out, how distributed a set of data is. So how far is it from the highest number to the lowest number? Or how far is it between the quartiles? How spread out is the data? So, and the key thing is a box plot is a statistical diagram. So we're actually going to be drawing box plots rather than just looking at them, essentially. So that's the first thing. A 5-figure summary is the second thing that's in our learning intention there. And a 5-figure summary is the 5 values we need to determine in order to construct a box plot. Okay, so a box plot is a statistical diagram, but you do need some numbers to be able to draw it, the same way if you were going to draw a bar graph or a bar chart or a pie chart or a line graph, something like that. You need some data to put on it. You need some numbers in order to construct it. A box plot is no different. We're going to need some numbers. It's called a 5-figure summary. As I said, it could be called a 5-number summary. And what are those 5 figures? Well, the 5 values that you need are these. Okay, and the good news is we're actually familiar with all these numbers already. So if you have a set of data, the 5 figures you need in order to draw a box plot are the lowest number in that set of data, the lower quartile, which we know is Q1, the median, which we know is Q2, the higher or the upper quartile, which is Q3, and the highest number. Okay, so the lowest and the highest number, you don't have to do any calculating to figure it out. You just need to look at it and see which is the highest and the lowest. And we know how to work out the median. It's the middle number in an ordered set, or the number which splits a set of data into 2 equal bits. And then we know how to find the lower and upper quartiles. They're essentially the median of the lower and the upper halves. So all revision so far. We've not actually learned anything new yet. Okay, so what is a box plot then? So a box plot uses these 5 values to make a diagram which looks something like this. So obviously we will be using specific numbers, but in general they look something like this. So I've already drawn a wee scale there at the bottom. This is why I said you will need a ruler for this. Okay, so we don't have any data, so this is just completely arbitrary just now what it would look like. But this scale along the bottom, I'm actually just going to write scale. This could be something like age, it could be time, it could be a height in centimeters, it could be a weight in kilograms, it could be anything. So it doesn't have to go from 0, but it could go from 0 up to something like, I think there's 15 intervals here, so we could go up to something like 30, and then each interval would then be 2. So the same way you would make a scale for anything, you make a scale for a box plot. Okay, I'm not going to fill in all the numbers. Okay, and what does it look like? Well, this is where our ruler comes in. Okay, and essentially these 5 numbers that we've got for our 5-number summary is how you make your box plot. So say your lowest number was 2. Okay, so you go to 2 on your diagram and you draw a small vertical line at 2. Say your highest number was 28. Go to 28, draw a small vertical line at 28, like that. Okay, and why is it called a box plot? Well, because the middle bits, the lower, the median, and the upper quartiles are what make your box. So say your lowest number was 6, your median was 8, and your upper quartile was 10. Like that. So you draw vertical lines at each of those. So essentially, for each of your 5 numbers in your 5-figure summary, you draw a vertical line above the scale where those would be. Okay. Then why is it called a box plot? Well, between the Q1, Q2, and Q3, you draw a little box around it, like this. And then the last thing you need to do, remember, this is your lower, and this is your lowest and your highest, I should say, your lowest number, your highest number, L and H. This can also sometimes be called, it is called a box plot, but it can sometimes also be called a box whisker plot. A whisker like the whiskers of a cat or an animal. Okay, a box whisker plot. And why is it called that? Because you need to draw some whiskers to join up to the other end. So you don't draw a line all the way through it, you just draw some whiskers connecting up the lowest with the box and then the box up to the highest. And that is what a box plot looks like. Okay, so you draw 5 vertical lines at each of the numbers in your 5-figure summary. You draw a box round Q1, Q2, and Q3, and then connect up the whiskers. You would also have some sort of title at the top. I don't know, it could be something like the ages of people in a class or something like that. But in this case, this is just an example, so we don't need a specific title. And that is it. That is everything that you need to draw a box plot. So I think without further ado, we can look at an actual example and we can do one from some real data. So I'm going to move my pens and like out the way. And we can move this out the way as well. In fact, we'll keep that there so it's not distracting us. So let's look at example 1. So we're going for a group of S4 pupils again to keep it relevant. So we've got a group of 11 S4 pupils. You might be wondering why I'm using the number 11 all the time. We'll see that in a minute. So a group of 11 S4 pupils were asked to record their screen time over 1 week. The results in hours are below. So your screen time as in how many hours in a week you spend on your phone. So I actually did get this data from sampling some people that I know, some family members and some friends, and my own. I'll leave you to guess which one of these numbers is my own screen time. Okay, so in a week we've got from 12 up to 27 and a kind of range in between there. Okay, so what we need to do is we need to determine the quartiles and the 5-figure summary for this data. Well, let's just go ahead and do that straight away then. So I'm going to use my blue highlighter so that hopefully it won't go through the page. Okay, so determine the quartiles and the 5-figure summary. Well, remember our 5-figure summary is the lowest number, Q1, Q2, Q3, and the highest number. Okay, well, surely the lowest and the highest are the easiest, aren't they? It's going to be that one and that one, because they're in order, have been nice to us. So that's the lowest number, that's the highest number. Q2 is the median, that's the middle number. And I said, why have I chosen 11? Well, 11's a good number because it means that you're not going to have to do any dividing and finding a number between something and something to get your median and your quartiles, just to keep it easy for us. So if we've got 11 things, our median is the 6th number in. So 1, 2, 3, 4, 5, 6. So our median Q2 is 17. And then of our lower half, we've got 5 things in the lower half. Okay, so our Q1 is 13, and we've got 5 things in our upper half, so it's going to be 21 is our Q3. Okay, so that is our 5-figure summary. Essentially, I'm going to write it out, but we don't really need to do anything else after that. So this is our solution down here. Just write solution to make it clear that this is our answers now. So our 5-figure summary, I would just write it out like this. So L equals Q1 equals Q2 equals Q3 equals and H equals, and then I would write them down. So the lowest number is 12, Q1 is 13, Q2 is 17, Q3 is 21, and the highest is 27. Okay, so that's part A Done. Construct a box plot to illustrate this. Well, let's go ahead and do that as well then. So take your ruler and let's do this together. I've handily picked my numbers and I've picked my ruler to reflect that, because we need to go from the lowest is 12 and the highest is 27, which is a range of 15. My ruler conveniently has 15 centimeters on it. So in fact, I'll move it up just 1 or 2 so we can see. Yep. So I'm going to draw a straight line for my scale, and then I'm going to draw my intervals on 1 to 15, like so. So just drawing little lines like that. Same way you would for any scale on any diagram, you need to measure them out. You can't just put 15 random lines. You don't need to do 15 incidentally, but this will keep it clearest. Okay, we need to go from 12 up to 27, so we've got 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. Okay, so that's our scale at the bottom. We're going to label our scale, so remember this is screen time, and it's in hours. And we should have a title up here as well, so I'll just put S4 screen time. Okay, and that's our title. So let's construct our box plot from it then. So for each of the numbers in our 5-figure summary, I need to do a wee vertical line. So my lowest number is 12, so I'm going to go to 12 and put a small vertical line directly above 12. Q1 is 13, so I'm going to go and put small vertical line above 13. Q2 is 17, so I'm going to go along to 17 and put a small vertical line above 17. Q3 is 21, so along to 21, small vertical line above 21, and the highest is 27, so right to the end of my scale and put a vertical line there. It's called the box plot, so let's put my box around my Q1, Q2 and Q3, like so. And remember, it is also in some circles called a box whisker plot, because I need to connect up my whiskers. So remember, don't just draw the line all the way through the diagram, just connect the box to the lowest and connect the box to the highest, like so. And that is us finished. That is us constructed a box plot for that data. Okay, so the next big question, I suppose, is why? I'm not sure how clear that green pen is there, so I'll go over it in my pencil, but the question is why? Why do we have box plots? Why are they a thing? Well, think about, why do you have any statistical diagram? A statistical diagram is to illustrate information. Okay, or to illustrate data. Okay, if you just look at all those numbers, you don't really get much of a sense of it. But if you've got it in a nice neat diagram like that, you can start to see things about it. You can see, for example, well, this box, if that's my quartiles, Q1 and Q3, essentially the width of that box is your interquartile range. Okay, so essentially you can see the range or the interquartile range just from looking at the diagram. You can't really see that from looking at the raw numbers, but you can if you look at the diagram. You can see that there's quite a big gap here. You can see that there's a big range between the lowest and the highest as well. Okay, which again, you can't really see just from looking at the raw data. So essentially it illustrates it in a way that you can see it a bit more clearly. And the next thing, the last part of our learning intention goes on to the last example here. Okay, in which we're going to talk about the main thing here, which is comparisons. Okay, so we're going to talk about comparisons. Now, why do we have to compare data? Well, because it's important to compare data. You need to have something to compare it against. Okay, now we're actually just going to look at this from our next example, which is over here. Okay, so we've got a second group of S3 pupils were also asked to record their screen time over 1 week. The results are shown below. So we have a second group this time of S3 pupils. Okay, and what we're going to do is we're essentially going to compare them to the ones we just did. So there are their numbers there. Again, we're talking about their screen time in hours over a week. You might already have some ideas if you were looking back at the numbers from the previous page about what we're going to see here. And we've got 3 tasks in this one. So part A is the same. Determine a 5-figure summary for the S3 data. Then part B, we're going to draw a composite box plot to illustrate this data. Okay, and that comes into the comparisons. Okay, so a composite box plot is what we're going to do. Okay, you should have heard the word composite before. When you think about like a composite number or something like that, it basically means more than one thing. Okay, the word composite means essentially more than one thing coming together. If you think about a composite class in primary school or something, you might have had a primary 5 and 6 class. So that's composites, 2 things that come together and make one thing. Okay, so we're going to draw a composite box plot. Hopefully you're ahead of me on what that's going to look like to illustrate the data. And then finally, we're going to make a few statements. So actual physical statements. I know it's maths, but we are going to be writing down some sentences comparing the data sets. Okay, so that's our task. So let's go ahead and try and do it then. I'm just going to keep that just in sight so we can see the numbers there, because what we need to do now is we need to, well, the first thing we need to do is our 5-figure summary. So for part A, what is our 5-figure summary going to be? Well, we're going to have the lowest number, we're going to have the highest number, we're going to have Q1, we're going to have Q2, and we're going to have Q3. Okay, I'm going to use my blue highlighter again. Hopefully, again, we can see they're in order, so we can just go ahead and start circling things. So that's my lowest number. Hopefully everyone agrees that's my highest number. My median, again, I've chosen 11, I hope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So my median is going to be the 6th one in. That looks like it's going to be the 16. Is that correct? Yep. So 16 is the middle one, so that's my median, which is Q2. And then my median of the lower half, my lower quartile, is then 11, so that's Q1. And my median of the upper half is 29, so that's going to be Q3. Okay, so again, some revision there. We know how to do those. So let's just write them down here. My lowest number is 8, my Q1 is 11, my Q2 is 16, my Q3 is 29, and my highest is 38. Okay, we now need to draw a composite box plot. So again, the first thing you need to think of when you're drawing your box plot is you need to think of the scale. Now, in a textbook or in a test or in the exam, you might be given the scale. It might actually have it already drawn for you, and you just need to draw the box plot on it. Obviously, in these examples, you don't have it already drawn for you because you're just doing it on a blank piece of paper. So we need to come up with a scale, but I'm sure we're all capable enough to do that. Okay, so I'm going to draw my 15 centimetre line again with my ruler and draw my 15 intervals. Now let's think about this. If I'm drawing a composite box plot comparing this to the S4 pupils, I should say this is all a comparison to the S4 data. Hopefully that was obvious. Okay, to illustrate this data compared to S4. Okay, so if I'm comparing it to the S4 data, well, we know from our previous box plot that we had to go up to from 12 to 27 for that one. So that was a gap of 15. But this one we need to go from 8 up to 38. So that's going to be a gap of 30. And we've got 15 intervals. So if I go from 8 up to 38, gap of range of 30, 15 intervals. So I'm going to have to go up in 2s here. So I'm going to have 8, 10, 12, 14, and so on, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, and 38. So again, I've chosen my numbers wisely so it fits in neatly like that. So there's my scale. Again, I'm going to have screen time in hours as the label for my scale at the bottom. like so. My title is going to be Comparison of S3 and S4 screen time, because that's what we're looking at, isn't it? We can put a wee underline for that title, and then I need to go ahead and start constructing my box plot. So I've got enough space here to put a wee gap between them, so I'm going to basically stack them on top of each other. I'm going to have the S3 one up here, and I'm going to have the S4 one down there like that. So this is where S3 is going to live, this is where S4 is going to live, like that. Okay, so how am I going to do this then? Well, let's go ahead and do the S4 one first, so we don't have to keep going back and forth. So S4, our 5-figure summary for that was 12, 13, 17, 21, 27. So I need to put a wee line at 12, like so. Now 13, hopefully we can all work out, is going to be halfway between 12 and 14. Like so. I think it was 13 next, is that right? No, 17, 21, 27. So 17 is going to be here. 21 and 27. So 21 is going to go in the middle, and 27 is going to go between 26 and 28. Like so. Do my box plot. Connect up my box, and remember it can sometimes be called a box and whisker plot because you need to connect up your whiskers, like so. Okay, so there is my box plot for, just keep that nice and neat, we don't want that wee bit sticking out there. It doesn't want to rub out, so we'll just leave it. Okay, so that's my S4 one done, but this is a composite box plot, so I need to compare them. So I need to do the S3 data now. I've got my 5-figure summary for the S3 data, so let's do it. My lowest is 8. Just make sure you're definitely going vertical. My Q1 is 11, that's halfway between 10 and 12. My Q2 is 16. My Q3 is 29, so we're jumping all the way up here. Just make sure that on the right one. And my highest is 38, so right to the end of the scale. Like so. And connect up your whiskers. Okay, you can feel free to write L, Q1, Q2, Q3 on your diagrams, but you don't have to, and they're absolutely fine like that, because anyone looking at it will know that it's a box plot. And that is part B done as well. So we've done part A and we've done part B. We've drawn a composite box plot. Now hopefully you're ahead of me for part C here, what we need to do with our few statements. It says make a few statements comparing the data sets. Well, what is the obvious things you can see about them? And this is where diagrams become more useful than just raw data, because if I gave you those 11 numbers and said to compare them to the 11 numbers previously, you could say loads of things like, oh well, that one's got a 16 which the other didn't have, and that one goes up to 38 which the other one didn't, and it's lower, but you can't really see much about it. You're just comparing individual numbers, whereas if you're comparing diagrams, then it's much easier to make the comparisons. So what are they? Well, when you're making comparisons in statistics, what you really want to talk about is you want to talk about the spread and you want to talk about the average. Okay, so what is the average data and what is the spread of the data? And you can make two clear comparisons here. Hopefully we can all see the S3's box plot is much wider. The two endpoints, the extreme values, are much wider than these two. And also the width of the box is much wider as well. Okay, so that means we can say that S3 screen time is more spread out. Okay, and then there's a phrase I would use for that as well, which is less consistent, but we'll come back to the word consistency in the next video on standard deviation. And then I've got this, which has popped up again, average. Okay, the last time we talked about averages was when we talked about mean, median, and mode. And there is one of those averages which you can see on this diagram, which is the median. Okay, because remember, the median is Q2. Okay, that is the median. So essentially, this bit here and this bit here. Okay, they're the two Q2s. Now, Q2 for the S4 is greater than Q2 for the S3s. So that means on average, you could argue that the S4s actually had more screen time, even though there was this one person in S3 which had way more screen time than anyone else. But on average, because it's the median that we're talking about, the S4s had more screen time. So on average, S4 had more screen time. And you can write since median is higher. And those are your two statements. Okay, so interestingly, the statements are arguably the most important part here, because what is the point in doing some statistics and working out all this, working out means, medians, modes, quartiles, ranges, drawing box plots? What is the point in doing all that if you can't do any analysis on it? The whole point in statistics is to find something out. So the key bit is actually the statements here, and we're going to see a lot more of that in the next video on standard deviation. Thank you.